Bash, Bourne Again Shell, is the default command interpreter on most Linux distributions. Writing scripts in Bash allows you to automate repetitive tasks, chain together the network and system tools you have already studied, IP, SS, nmap, apt, system kachel, and build small security utilities. In cybersecurity and DevSecOps work, Bash scripting is essential for reconnaissance automation, log parsing, batch host scanning, and integrating checks into a delivery pipeline. This course covers the three foundations of any script: variables, conditions, and loops. 1. The shebang and script execution. Every Bash script should start with a shebang line, which tells the operating system which interpreter to use. !bin/bash. This must be the very first line of the file. To run a script, you generally make it executable and then call it chmod plus x myscript.sh /myscript.sh. Alternatively, you can run it by passing it to the interpreter directly, bash myscript.sh. Comments begin with the hash symbol, hash, and are ignored by the interpreter. 2. Variables. A variable stores a value that you can reuse. In Bash, you assign a variable with no spaces around the equals sign. Name equals Alice. Port equals 443. Writing name equals Alice with spaces is an error, because Bash would interpret name as a command. To read, expand, the value of a variable, you prefix its name with a $sign. Echo hello $name. Echo the port is $port. The curly braces in $port are optional but recommended when the variable name touches other characters, for example $file_backup. Bash variables are untyped by default. Everything is treated as a string. The value 443 is stored as text unless you force arithmetic evaluation. Quoting matters greatly for security and correctness. Double quotes allow variable expansion. Echo $name prints the value. Single quotes. 2. Prevent all expansion. Echo $name prints the literal text $name. Always quote variables that may contain spaces or special characters, for example $filename, to avoid word splitting and injection problems. Command substitution captures the output of a command into a variable using the $, syntax, preferred, or backticks. Current_date equals $date host_count equals $nmap sn 192.168.1.0 out of 24, grep c nmap scan report. Special variables you must know. $0 is the name of the script itself. $1, $2, $3 are the positional arguments passed to the script. $hash is the number of arguments. $@ represents all arguments as separate words. $? Holds the exit status of the last command. 0 means success. Any non-zero value means failure or error. $$ is the process identifier of the script. Example using arguments. !bin/bash. Target equals $1. Echo scanning target. $target. Running. /scan.sh 10.0.0.5 makes $1 equal to 10.0.0.5. Environment variables such as $home, $user, $path, and $pwd are provided by the system and are available inside scripts. You can create your own environment variable with export so that child processes inherit it. Export API_key equals secret. Arithmetic is performed inside double parentheses or with the let keyword. Count equals $5 plus 3 total equals $port 2. 3. Conditions. Conditions let a script make decisions. The basic structure is if, condition, then. Commands. Elif, other_condition, then. Commands.else. Commands, phi. The block always closes with phi. If reversed, the semicolon before then can be replaced by a line break. The classic test uses single square brackets, which is actually a command called test. Spaces inside the brackets are mandatory. $A equals $B is correct, but $A equals $B is an error. String comparison operators. Equals or equals checks equality. Equals checks inequality. $var is true if the string is empty. $var is true if the string is not empty. Integer comparison operators do not use less than or greater than for numbers inside single brackets. EQ equal. Ni not equal. LT less than. La less than or equal. GT greater than. GE greater than or equal. Example. $port equation 443 tests numeric equality. File test operators are very useful in security scripts. File is true if the file exists and is a regular file. Dir is true if the directory exists. ePath is true if the path exists, any type. R, W, X test read, write, and execute permissions. S-file is true if the file exists and is not empty. Example. If f/etc/password, then echo password file present. Phi. Logical operators combine conditions, and means and, vertical bar means OR, and, negates. Inside modern Bash you can also use double brackets, which are safer, support pattern matching, and allow and vertical bar directly. $name == A and $port GT1000. The case statement is a clean alternative to many ALIF branches. Case 1 $in. Start, echo starting. Stop, echo stopping. Echo unknown option. ESAC. Each branch ends with, and the asterisk is the default case. The block closes with ESAC, case reversed. 4. Loops. Loops repeat commands. The for loop iterates over a list of items. For IP in 192.168.1.1, 192.168.1.2, 192.168.1.3, do. Ping C1 $IP done. Every loop body ends with done. You can iterate over the output of a command or over files. For file in /var/log/log, do. Echo reading $file. Done. AC style numeric for loop is also available. For I = 0, I less than 5, I++, do. Echo iteration $I. Done. The while loop runs as long as its condition is true. Count = 1. While $count $5, do. Echo count is $count. Count = $count plus 1 done. The until loop is the opposite. It runs as long as its condition is false, stopping once it becomes true. Reading a file line by line is a common pattern. While read R line, do echo line. $line done less than host.txt. Loop control keywords. Break exits the loop immediately. Continue skips to the next iteration. 5. Putting I together. A security example. #!bin/bash network = 192.168.1 for host in $sec110. Do IP = $network.$host if ping C1 W1 $IP greater than /dev/null 2 greater than and 1, then echo $IP as UPLs echo $IP is down phi done. This script builds addresses, pings each one, checks the exit status through the if condition, and reports the state. The redirection greater than /dev/null 2 greater than and 1 discards both normal output and error output. 6. Good practices in security. Always quote variables to prevent word splitting and command injection. Add set E to stop the script on the first error, set U to fail on undefined variables, and set O pipe fail to catch failures inside pipelines. Validate arguments. Check $# before using $1. Never build commands from unsanitized user input. This can lead to injection vulnerabilities. Give scripts minimal permissions and avoid running them as root unless necessary. Mastering variables, conditions, and loops gives you the building blocks to automate reconnaissance, parse logs, and integrate security checks into a continuous integration and continuous delivery pipeline.